scripting with SamUL. And for this example, I'm going to show you a script that was written for an analysis by my colleagues at NREL. But before I do that, I'll show you that there are some resources for learning more about the script. We do have a sample file, this scripting with SamUL example. Which has several examples of scripts for different applications. And just to describe what SamUL is again, SamUL is basically a programming language. It's a scripting language that allows you to automate repetitive analysis processes or complex analyses. So you can write a script to assign values to variables. You can make calculations in the script, so there are math functions in the script, and then you can also read values from text files. So you can set up a CSV file, for example, with values, and then write a script to pull values from that file and make calculations on those values, and then populate SAM input variables with the values. You can manipulate simulations, so you can run simulations repetitively from the script, and you can set up different kinds of simulations, and then you can write simulation results to files, so you can create a text file with results of interest by pulling values from the SAM results. So it's pretty powerful, and so this sample file has examples of the script, so you can see what the script looks like and try them out and use these as code snippets to build your own scripts. There is a SamUL guide on the help menu that has a description of the language to help you get started. We actually have a more up-to-date version that hasn't been published yet, so if you're interested in working with this script, please email me and at the SAM support email address, and I can get you a copy of a more up-to-date version of this. But this is not an exhaustive manual. It just kind of has enough information to help get you started. And then I think the Power Tower sample file, if you're interested in modeling Power Tower systems, the Power Tower sample file has a script in it as well. So you can, if you want to see more examples of code, there's some there. So the example that I will show you is this one here. So, this is for looking at rooftop PV systems in a bunch of different locations. So what they had to work with was a set of addresses, and so you can see this Excel spreadsheet. It looks like there were about 30 different locations they were interested in, and each location was identified by an address. And somebody did some estimates of the size of the size of a PV plant based on the rooftop area here, and then there's also the an installation cost associated with each location. So this was the input data that was handed to the analysts, and the question was, what is the levelized cost of energy for each of these systems? So one way to do this would just be to set up 31 different SAM files and put in the PV capacity and the cost for each system and run it, and then build a spreadsheet with the results. But instead of doing that, we wrote a script, which I will show in this file. So because the only system description that we have is the PV capacity, so the system capacity. For that reason, we decided to use the PV watts model. Since you can specify, that's the only input is the DC capacity. It would have been possible to do this analysis using the component-based models and choose an array and inverter for each system, but that would have been a lot more complicated. To set up this file, the first thing the analyst did was to set up a case with the based on the PV watts technology model, and then to write a little script that would read the system capacity and the cost and the installation cost from the file and populate the appropriate inputs. So we put the system capacity here in DC rating and the cost so notice here that the cost is the system cost. The module cost category is being used as a proxy for the system cost. So all of the other cost categories are set to 0 so that we can specify the entire system cost. And then for the climate, since the input, the only information we have about the location is, or about the weather file is an address, we're going to use the location lookup feature and enter the address and have look up the Perez satellite data from the web. So I won't go through how the script works in detail here, but basically what it does is open an input file, which I'll show you in a moment, and read the address from the input file, and then also read the DC capacity of the system and the cost. And I neglected to mention another input, which is the utility rate, the retail rate that the project at which the project buys and sells electricity. and then there's a set of commands to set the value of the input variable, and then simulate. We run once you've set the input variables, then it runs the case, and then reports the results, and writes the results to a file. I'll run the script so you can see what it looks like. But let me first show you the input file that we're using here. So we started with this spreadsheet that I showed you that had the values of interest, but also had some other stuff that Sam doesn't need. So we built a CSV file with just the input variables that we need. So we have an address. So Sam's going to read the address in, and the PV size, and these cost variables. We return to the script. We can see that it reads those these are the commands where it reads in. It's reading values into arrays, and it finds data in the CSV file just by counting columns in the file. So this is column 0. This is column 1. So if you want to get this address, then it'd be column 0. Column 2, row 1. So that's the indexing method for finding data in the CSV file, and you can see that in these variables. So let me run the script, and it's the area down at the bottom of the screen here is for displaying information using this outline command. So this is just giving us some feedback so we can tell that it's doing something. And it's cycling through each address in the file and calculating both an LCOE and a payback period. And if I look at my folder, I can actually see it. It's downloaded a weather file, these TM2 files, and it's storing it in this folder. And then it's reading and writing to this output CSV file, which I won't open until the script is finished running. Okay, so now it's finished running. I can review. I can use the scroll bar here to look back through this window. And if I go back to my folder and look at the output CSV, so this is the file that the script created, and it got the latitude and longitude. So I provided it with an address, and it got the latitude and longitude from the location lookup feature. Here's the DC rate, which was an input, and then the LCOE nominal and payback period were outputs. So this is pretty powerful tool if you're doing doing a lot of runs, a lot of repetitive runs. It can really save you a lot of time. then if you make so in this file, we were only changing a few of the input variables using the script. The utility rate, the PV capacity, and the others that I mentioned. But all the remaining variables are set in the case. So all the financing assumptions, incentives, which there are none, it looks like, these were all set up in the case. So if you you could adjust the analysis period and then rerun the script quickly without any effort. Whereas if you're doing all of this by hand, it would take forever to run, to experiment with different input values. Okay, so that's SamUL. I'll pause for questions about that.
Thank you. At this time, we will begin another question and answer session. To ask a question, you may press star 1 on your touch-tone phone. Please unmute the line and record your first and last name. One moment, please. And currently, no questions are populating.
Okay, I'll take a question here from the QA window. Somebody noticed that among the simulation options, there's this simulator options button, and that you can change the time step here. This is really a placeholder. We are working on future versions of SamUL will run at different time steps. Right now, it only runs hourly, but I know for the trough model, for the next release later this year, we're planning that one will run at 10, 15-minute resolution. Of course, to run at higher resolution, you need weather data at higher resolution. So the answer to that question there is, for now, I would say that SAM runs as an hourly model, and we'll be adding higher resolution in later versions. There is some capability now to run at higher resolutions for some cases, but it's really a test simulation mode.
No questions still on the phones.
Okay. And again, any of these written questions that I haven't answered, I'll write answers to and post on the website later.